Across the semiconductor industry, especially in the microelectronics and the sensor innovations, we are
Mhm.
witnessing these irreversible shifts, driving the integration of AI and quantum computing into materials discovery. Let me just highlight three of them maybe. So one is being the eco materials mandate, with regulatory pressures on rare earth as risk factors. Sensors and chip makers are under pressure to pivot. So this accelerates the use of AI to identify alternative materials for, say, MEMS, power devices, and even packaging.
With regard to the trends, some of the things you put up earlier, we definitely see regarding regulation and safety. I mean, there's more and more scrutiny these days on chemicals and materials. PFAS being a great example that everyone knows about. Things that have been in use for a long time are now being seen as hazardous and need replacement. And so there's a major push to fix all of this. And it's important that these alternatives work from both a performance and a cost perspective and a manufacturing perspective. So all those pieces have to fit together.
Let's say battery materials, right? So AI and quantum simulations, help you to identify new solid state electrolytes and you can say, cathode materials. Now companies like Toyota and QuantumScape, they are using AI to discover solid state electrolytes that are safer and you can say more efficient.
So different material systems, alloys, multifunctional materials, traditional materials, polymers, rubbers, these different types of materials, adhesives, they have different chemical or molecular structures. And as a result, you have to solve these different problems with different sets of, let's say, computational models. And when you look at basically our entire universe of, let's say, different elements that exist in the world and everything, right? So there is a huge number of, let's say, methodologies that are developed specifically for a specific type of material system. And that's actually makes this, let's say, design space extremely huge and difficult to manage. And this is actually where AI can help to kind of organize these types of knowledge and help people to kind of pick the right algorithm, pick the right methodology for their best use.
We shall be looking at what could be the growth opportunities here. So we could identify a few. They are some of the topics: accelerating time to market by rapidly screening candidates using various kind of simulations, enhancing molecular design by leveraging quantum computing for high accuracy property predictions, improving R&D efficiency by integrating such kind of instrumentation and AI workflows, discovering new materials via quantum-enabled explorations, and fostering cross-functional innovations by uniting artificial intelligence, quantum computing, and domain expertise in material science.